In this segment, we're going to talk about the differences between black holes and supermassive black holes. Let's start with black holes. A black hole is a mass that has collapsed to such a small volume that its gravity prevents the escape of radiation, of light. Light can't escape. Also, in addition to being a mass, it is also the volume of space from which the radiation may not escape. The volume of mass around the mass. The volume of space around the mass from which radiation may not escape. An example of a black hole is Cygnus X1. So if we look at this figure from your textbook, it's actually in the appendices, you will see we're looking at the northern hemisphere sky and in the month of November. So let's say you're looking in mid-month and you look up at the sky around 8 p.m. in November. You would see the constellation Cygnus in the sky. Let's blow up this region. So we look in the sky and we see this cross in the sky representing Cygnus. This top star is Deneb. And about halfway down below the cross point, this is where you're going to find Cygnus X1, which is a black hole star. Here we are looking at Cygnus X1 in the optical light. It was taken during the Digitized Sky Survey by the Chandra Telescope of NASA. And notice in the center, we see this square box, and that is where the black hole star is located. Now, the diameter of this image is 700 light years across. So you can see that we are looking at a very small area in this very large area of star formation. Now, a black hole alone is totally invisible because nothing can escape from it, not even light. But if you put a black hole very near another star, so it's in a close binary, then matter from the other star can flow into the black hole, and it will flow around the black hole like water going down the drain in what's called an accretion disk. And that disk will become hot enough to emit X-rays, so we can see the disk around the black hole, but we won't necessarily see the black hole itself. So one way to look for black holes is to look for the accretion disk around the black hole. And since Cygnus X1 is an X-ray source, this is how Chandra had found it. Now this is an artist's conception of what Cygnus X1 looks like. The black hole is inside this event horizon, which I've colored in purple. The black hole is in a close binary with this secondary star, which is a supergiant B0 star, the corner of which I've colored dark blue. Now this two-star system is so close, it's closer than Mercury is to the Sun, that the black hole star can basically pull the gas from the B0 star. So the gas is leaving the B0 star, and because the system is rotating so fast, the gas doesn't fall right on the black hole. Instead, the gas misses the black hole, and it goes around like water going down the drain, forming this accretion disk. And it's the accretion disk that's emitting the X-rays that Chandra sees. So one way to look for a black hole star is to look for the binary and then to look for the X-rays coming off the binary. But this won't necessarily guarantee that the central star is a black hole. It could be a neutron star. Now, if the compact object mass that I colored purple in this diagram, this purple, if that compact mass object is less than 3 solar masses, then the object will be a neutron star. If, however, the mass of the compact object is greater than 3 solar masses, then it's going to be a black hole star. Now, since we know the mass of the compact object in Cygnus X1 is 10 times the mass of the Sun, we know that the compact object has to be a black hole. So that's the second way you can determine whether the compact object is a black hole, and that is to find the mass of the compact object. The first method, look for the X-rays. Second method, find the mass of the star. Now, in the first method, if you find X-rays and the X-rays are continuous, then most likely it's going to be a black hole. But if the X-rays are coming in pulses, then it's going to be a neutron star. So returning to the definition of a black hole is a mass. It is a star. It is a star that has mass. It's a single object. It is a star. Now let's go look at supermassive black hole. Supermassive black holes are the centers of large galaxies. Now the masses of these supermassive black holes are more than 1 million suns. So what this means is that there is more than 1 million solar systems in the centers of these very large galaxies. So you can see that a supermassive black hole is not the same thing as a black hole. A black hole is a single star. A black hole is a star that has greater than 3 solar masses, but somewhere less than 20, 25 on average solar masses. It doesn't have hundreds or thousands or even millions of star systems in them. A supermassive black hole does, and it is the center of a large galaxy. An example of a supermassive black hole is